In this lesson, we're going to see some practicals around cryptography. In fact, we'll be introducing one of the most important cryptographic libraries in the world, which is the OpenSSL, one of the very important library. At least 99% of the world's traffic is encrypted using OpenSSL. Very important library. And we'll be using the OpenSSL tool, which in turn use the OpenSSL library. And we'll be looking at the hash functions we have seen. We'll be creating hashes of different files and data. That's another thing we'll be doing. And in the end, we'll see corresponding libraries from Windows, which is a slightly different library, which is very similar to OpenSSL. So that library is called crypt32 or KSACDD, which I have worked myself while I was in Microsoft. So without further introduction, let's get into the topic. It's a very important topic, both OpenSSL as well as crypt32. So first, what we're going to do is we're going to install OpenSSL. Most of the Linux systems has OpenSSL installed by default. So OpenSSL. In Windows, OpenSSL doesn't come by default. We need to install it. That's what we are going to do first. Before we get into that, we'll talk a little bit about OpenSSL and some of the related libraries. So OpenSSL is one of the very important libraries when it comes to security and cryptography in general. In fact, our pillar number 1, which is the cryptography, is completely implemented using OpenSSL. In fact, in my knowledge, there are only 2 libraries in the world which implements these artifacts, all this hashing, encryption, PKI, all that kind of things we are going to discuss. Basically, the pillar number 1, only 2 libraries I know so far, at least in the public world. OpenSSL being the open source version of it. Another is the crypt32 in Windows. Crypt32.dll will not be dealing with crypt32 much, but if you're using Windows version of the certificate manager and things like that, we'll be using crypt32 internally, and it has a kernel mod equivalent called KSACDD. So this is how this library is implemented in kernel of Windows, which is the equivalent of crypt32 in Windows. So this is the proprietary Microsoft implementation, but right now anything and everything is using OpenSSL. Probably 99.99% of the whole traffic in the internet is using OpenSSL in my knowledge. So one being OpenSSL, the other being Microsoft crypt32 implements almost all the cryptographic algorithms and functions, hashing, encryption, PKI, all the things we have discussed so far. Now, most of the training we will be using OpenSSL, but I'll be showing you a couple of commands from crypt32 as well. We will not be analyzing if it is coming from crypt32 or not. It's not part of the training, but most of the practical purposes will be ignoring crypt32. It's a pretty old implementation, probably slightly older than OpenSSL. Not sure about the history, doesn't matter. So crypt32 is a very famous library. In fact, if you look at the Microsoft code, the crypt32 code, you will see contribution from people like Wideye, who was one of the cryptocurrency pioneers, who originally wrote this library when he was working back in the Microsoft days. So a lot of stories around this particular library. It is proprietary. We don't have access to the code. That's enough about crypt32 and KSACDD, which is the kernel mod equivalent in Windows. Now, that being said, let's go ahead and install OpenSSL in Windows. If you're on Linux, you don't need any installation. You can simply type the command OpenSSL. But if you're on Windows or some other operating system, probably even Mac has OpenSSL installed by default. But otherwise, if you don't have it, you can install. That's what we are going to do. So one of the things with OpenSSL is that it doesn't offer pre-built binaries. It is just the code. You can build it yourself. There are build instructions available. But what I'm going to do is that I'm going to go to a third-party site and just download the pre-built version to make things easy. As usual, we are going to Google and going to type OpenSSL download for Windows. That is what this laptop is using Windows operating system. So OpenSSL download for Windows, that's what I'm searching. Pretty much we can go to the first link. There are other pages as well. Have a look at things before you download. I have downloaded from this particular website before and it has been okay. So in this case, I have downloaded the exe version of it, the executable version. You can go for the MSI as well. I didn't go for the light version. I gone for the full version. So go for the full version and it is around 250 MB size and it'll download like so, which is around this size. You can double click on the executable and start installing. You can select all the default options and it'll get installed in this particular location right here, which is C program files, OpenSSL 64-bit, then bin. That's where the OpenSSL executable comes. We'll be using this for the rest of the training, and these are the binaries available. If you want, you can check the different libraries and files inside OpenSSL, but most of the implementation is done in these two libraries. The basic cryptographic operations and code is lying in this particular DLL, libcrypto, which is the crypt32 equivalent in Linux or in the open source world. Now let's use this for creating some of the hashing cryptographic hashes we have discussed so far. So we have seen the modulo operator as a weak hashing algorithm. Let's see some strong ones like SHA-1, SHA-256, SHA-512, etc. Let's see that. Right now I have not added this particular folder to my path. So what I'm going to do is that I'm going to cd to this particular folder right here, change directory, to access these binaries. If you want, you can use the absolute path. It's your convenience how you want to access it, but the binary is present in this particular location. In my case, I'm going to cd into this location. So this is where the installation has been done. Type the command OpenSSL. You will see a lot of options out here, all mostly cryptography related. And we are going to use something called DGST or digest. Digest is another word for hash. So these are the different available options. We'll be using some of these options: MD5, SHA-1, SHA-256, and SHA-512. If you want to try other ones, feel free to, but these are the ones which is available. So what we are going to do is that we are going to create a file, a test file, a hello world file, and create the hash for that. By the way, SHA means secure hash algorithm. So there are different versions of it: 512, 256, and SHA-1. SHA-1 and SHA-256 is the most commonly used ones, but these days 512 is also common. There are a lot of other similar algorithms. Now what we are going to do is that we are going to create a file at a random place. So I'm going to name this file as file for hashing, just a text file. I'm going to put hello world inside the file. You can put any data you want. For example, right now I have put hello world. So I'm going to copy this particular path right here and coming to my OpenSSL. So the command is OpenSSL DGST, then the name of the hashing algorithm you want to use. In this case, I'm going to mention SHA-1, and then the absolute path of the file or the file location. So in this case, I have just one file. This should ideally work, and it has worked, and it has created the SHA-1 hash of that particular file right here. So this is the SHA-1 hash. As you can see, the hash itself is pretty bigger than the content of the file, but we can put any content in that file, including binary file. This is a text file, but you can have binary file as well. Now, this is the hash of this particular file, or a representation of that file. Now, what I'm going to do is that I'm going to make a small modification to the file. So let's see that. So I'm going to put a 1 in the end. Hello world 1. Very small modification. And I'm going to save the file, Control S. And again, I'm going to do the same thing which I did. As you can see, the hash has changed drastically. There is no relation between the previous hash and the new hash, even though the file has been changed only a little. Just one number has been changed. Now let's make sure that the change is only 1 bit. There was more than 1 bit change. Now what I'm going to do is I'm going to make it 2 so that the change is very minimal, more minimal than before. Again, I'm going to compute the hash. As you can see, again, a completely different hash. Now, without changing, I'm going to compute the hash. I'm not going to make any changes. Let's see if we are getting the same hash. No changes. We got the same hash. The exact same hash. File has not changed. So here itself, we are observing the properties of hashing. If the file is changed a little bit, a small bit, hash is completely changed. Now, the file is not changed. The hash remains exactly intact. Not sure if you're able to understand the magic around it. By the way, what we have just did is something called cryptocurrency mining all of a sudden. This is exactly what cryptocurrency mining does. It has a file just like this, and it changes that file a single bit, a non-repeatable number. Single bit or a small change is done, and keep calculating the hash like we did. And what is the target? To make this particular hash below a certain value. That is what cryptocurrency mining is all about. The network difficulty of the hash calculation target. It is as simple as that. So even in the beginning of the training, without getting into much details, we are able to understand certain things. Now, if it is that simple, everyone will be cryptocurrency miners. Why do we need all this hardware infrastructures and things like that? Because you need to create hundreds and thousands and millions and billions of hashes like this to get to a minimum number, because this number is completely unpredictable. There's no way to predict this number. We have no clue what we are going to get when we add or change this bit right here. Control S. I have no way to predict what is going to come. So I got a random number, more or less random number like this. Now, what is my target when I do cryptocurrency mining? Getting this particular number under certain value by doing more or less brute force of changing this particular number. For that, I need a lot of compute to calculate all the hashes. Of course, on a predefined algorithm. It may be SHA-1, it may not be SHA-1. Let's see some other hash algorithms. So this is SHA-1. SHA-2 will be bigger than that, 56, SHA-2 56. As you can see, it is bigger because it is 256. 512 will be bigger than this, as expected, 512. Now, another one is MD5, which is not really cryptographic anymore. MD5, it's very small, smaller than SHA-1. So it is considered bigger the hash number, like 512, more secure it is. And smaller the hash, like MD5, less secure it is. But smaller the hash will be easier to compute. We need to compute big number in this case. In this case, it is very small number. So this is easier to compute. So if you don't need all the security, if you're trying to represent a file, you can use MD5. Now, if you want to mine cryptocurrency, probably you need to use something like 512 so that it is secure as possible. So don't worry about the cryptocurrency example I gave if you are not able to understand, because it has a lot of other moving parts. I was just explaining something came to my mind. But the idea here is to understand hashing, not to get into cryptocurrency or anything for that matter. There are so many other use cases of hashing. Now, as I said, this can be a password. For example, if it is a password and you're creating the hash, and if you're saving this particular bit right here, no one will be able to understand what is a password. At the same time, you can verify the password as well with this particular number. When the user gives, calculate the SHA-12 of the string which is given by the user and check that string is equal to this particular string. If not, the hash is wrong, or the password entered by the user is wrong. At the end of the day, in the secondary storage or in the database where you are saving the password, you are not saving the password, you are just saving this particular hash of the password. That's how password can be securely stored in terms of hash. This is also another example I gave in the previous lesson. Again, applications doesn't matter to us for the time being. I'm just talking about it because it's just coming into my head right now as we speak. Now, is it the only way to create hashes in Windows? Not really. So there are other things like OpenSSL, like I mentioned, potentially using crypt32, which is specific to Windows operating system. The tool is called certutil. Let's see an example. So in this case, I'm using the Microsoft Copilot just to get the command straightforward and easy. How do I create SHA-1 using certutil? And it's giving the command. Let's see if it is correct. So what I'm going to do is first I'm going to check if the command is available. Certutil util. Cert_util is available. Now cert_util hash file, then the file name, then the hashing algorithm. That's a format. Cert_util-hash file. Then this is a file we need to compute the hash, and then SHA-1. So we got the SHA-1. Let's compare the SHA-1 with OpenSSL. So this is the MD5. Ideally, we should get exact same hash, and we did. So D4E. Normally I check the end and the beginning. 63B6. I'm pretty sure this cert_util is using crypt32, completely unrelated library. I'm positive that they don't even have a single line of code same cert_util. You can check using process monitor or something like that. The training gets complicated if I get into the verification, but I'm positive this is going to use crypt32 in Windows. So this is the DLL I'm talking about. This is the Microsoft equivalent of OpenSSL. And there are a couple of friends of this library right here. Most of them starts with crypt, mostly the cryptographic implementation of all the algorithms we have seen or discussed so far. Now what matters to us is that as long as the algorithm is same, as long as the algorithm and the file is same, the hash remains the same. Single most important property. There are some other tools in Linux to calculate the hashes, but almost all of them has similar code base as OpenSSL. But cert_util, I'm pretty sure it doesn't use OpenSSL because Microsoft has its own cryptographic libraries. So we have seen OpenSSL as well as crypt32. We have done some examples using the OpenSSL binary to create the hashes. In fact, pretty much everything OpenSSL can do, crypt32 also can do. In fact, most of the native Windows implementation, including the kernel, using crypt32. But otherwise, all the Linux world, probably 90% or 99% of the world is using OpenSSL, like I mentioned before. So we'll be seeing OpenSSL every now and then when we discuss cryptography. And that's all I wanted to mention in this particular lesson, and I'll see you in the next. Thank you for watching.